Hey, this is Altbier. I want to welcome you to the Hardware Hacking Village lab number 1. This lab is going to have us walk through building our first circuit and running some code on it with the Arduino. So let's get started. The first thing that you're going to need for this lab is the Arduino Nano. This has the headers, the header pins already soldered on it. If you haven't soldered yours together yet, you'll need to do that. And then we're going to walk through building a circuit using the strip board that was in the kit, as well as using these two female headers and a 100 ohm resistor and an LED. This is the basics that we're going to put together for the circuit. We will also need a piece of wire, copper wire. I chose black. You can choose whatever color you want. So let's step through what it is we're going to be building. So here is the circuit schematic that shows we're going to plug in a resistor and an LED coming off Arduino pin D3, which is a Pwm pin. That means it supports pulse width modulation, which will be important in some of the code we write for it later. And it comes around to the ground pin. We have the actual strip board connections are listed here. So we're going to use I1 through 15 and K1 through 15 for the Arduino. We're going to plug in the resistor into L10 and O10. The LED is going to go into P10 and Q10, with P10 being the anode and Q10 being the cathode. And then a wire from R10 over to L12, which brings it to ground. As far as the anode and cathode on the LED, what we have is one leg is longer than the other, and there's a flat notch on one side. So the side that has the shorter leg has the flat notch. That is the cathode side. So the longer pin is the anode. So that's how we know the direction to plug that into. So let's go ahead and get started. We have our pins. Our header pins that are female are going to go into the I row and the K row, going 1 through 15. Now, because they do wobble a bit, what we're going to do is put in some male header pins to hold it in place. And if you break away a 7 length of male pins, that 7 pin length is perfect to give us 90-degree angles. And then we will flip this upside down, and we will go ahead and start soldering this up. So the first thing that you want to do when you're soldering is make sure that your tip is tinned. So we'll add a little solder to this, and try not to drip solder onto the board. All right. Now the first couple are kind of wobbly because of those male pins sitting in top. So I'm going to get the 4 corners, and then we can remove those. Okay, there's 2. And last one. Okay. I got a little extra chunk of solder there. That looks good. So now we can remove these spacer pins that were just there to hold their alignment, and we can solder the rest of the connections in. And once we get all of these connections, this is the majority of the soldering that we're doing because there's 15 on each side. That's 30 connections we have to solder. Then we just have like 6 more for the wire, the LED, and the resistor, and then we can start programming this board. Now you might be asking why we're putting this female header pin on here. That's mainly so that we can reuse the Arduino in other projects. You could solder the Arduino's male pins directly to this board, but then you can't easily remove it. So the Arduino is stuck on that board and can only be used for projects on that board. So I like to use the female header pin to allow me to remove that as we're working other projects. Because these are handy little boards, the Arduinos, and I always seem to need one for something. So I'm being careful to get the iron onto both the pin and the pad. That way the solder will connect that joint nicely, as opposed to if only one of those was heated up, it wouldn't give me a good solder joint. Alright, we'll take a look at those, and just need to add a little more solder to this one. Alright, so now we have our header pin on there. We just have to work on the resistor next. And as we said, the resistor is going to go between L10 and O10. So let's look at the 10 and put in the 10 for L and 10 for O. Use our plier to pull it a little flatter. And I spread those legs out so that it's staying in place. It's not going to fall through. And let's get that soldered up. Alright, that looks good. Now what we want to do is trim these legs off so that they're not in our way. And when we're trimming the legs, we want to make sure we're not cutting into our solder joint. Just trim right above the solder joint. That way we keep that solder joint nice. Alright, now we'll get our LED. And as we said, it goes anode is the big one, cathode is the small one. And we're going to put the anode into P10 and the cathode into Q10. We're not going to push it all the way down because I don't want the plastic of the LED to melt when we're applying heat. So we'll get it right about where we want it, and we'll bend the legs out, and then we'll let it hover there as I hold the board so the LED stays in the air. And then we will solder that into place. Alright, and so that's good. Now let's trim his legs off. Same way we did the other ones. We're going to make sure that we don't cut into the solder joint. Now all that's left is a wire. So we're not going to need this whole wire. Let's trim it down. And then we're going to trim the plastic off of one end, being careful not to cut into the copper. And then we will bend this at a 90-degree angle so that it can go into the hole. And actually I'll bend this around a little because it's going to go from here to there. And then we'll do a quick measurement to see, do I have enough or too much? I think we still have a little too much wire there. Cut a little off. And then we're going to do the same thing on this end as far as stripping that plastic off, being careful not to cut into the wire. And then we will bend it in a 90-degree angle down. And now we're ready to place this. So this is placing into R10 and L12. I might need to use my pliers to move the wire into the hole. There we go. Alright, and then I'm going to use the pliers as a rest to hold that wire in place while I'm soldering it. That way it doesn't fall out. Alright, let's get that soldered up. Now these solid copper wires, they are pretty thick, so they take a little while to heat up. So give it some time on the iron to get to heat. Don't feel discouraged if the solder is not melting on it right away. That's because it's a thicker connection than those component legs that we've been dealing with. All right. Okay, we see both of those are looking pretty good. That one is still a little long, so I'm going to trim it. And when we're trimming wires that are this short, be sure to cover them. That way they do not fly out into your face. And that is it for our circuit. We have a nice circuit ready to program. So let's talk about what we're going to do to program this thing. So the circuit that we built, we're going to use 3 different pieces of code on it. The first code is a simple blink using a digital write. So this is your traditional blink 1 LED code that every Arduino has an example of. So that's what we're going to do first, just to test out the circuit. So what we'll do is we'll open up our Explorer, and when you double click on a .ini file, that's the file type of Arduino code. These are just text files, but .ini is associated with the Arduino IDE. So when we open that up by double clicking it, it automatically launches the Arduino IDE. And what we have is that code that I was just showing you in the PowerPoint. So we have our comment. This first line just defines the pin number that we're using. This is digital pin 3. That is not the physical pin number on the Arduino's package. It's what the Arduino is programmed internally to recognize as a pin digital 3. So we're assigning that. And these are values that are actually printed on the Arduino. So you can see which is D3. That's what we're using is digital 3 for this LED. And that's one that has a pulse with modulation, although we're not using it in this code. So we take that pin number and we're going to set the mode as output. And then we're going to use a digital write to that pin number with a value of high, which digital write is binary. So you're going to have a 0 is a low and a 1 is a high. And then we have a delay of 2 seconds. That's 2,000 milliseconds. So delay is listed in milliseconds. So the first time that you're using your Arduino IDE, you may have to set it for what board you're using. That is done under Tools. So you set Tools, and then you have a board type, which I chose the Arduino Nano. You have a processor type, which you have like ATmega 168 or 328P. In my case, and probably your case if you're using the Arduino that you got in the hardware hacking kit, you're going to want to choose the version of 328P that says old bootloader next to it, because those chips use the old bootloader. And then port refers to what COM port, which is on your system, whatever USB port you're plugging the Arduino into, it'll define that COM port. So in mine, it sees from the last time I plugged it in, we have a Nano 328P old bootloader on COM 3. So we'll verify our code, and then we will upload our code. Now, while that's verifying, I do want to show what I'm going to use to plug in my Nano. So in the hardware kit, you should have gotten a USB tester. I always use a USB tester when plugging in a development board into my computer, because if I have a short or some other problem with the electronics, I don't want to damage my PC's USB port. So that's all that we're doing. We don't care about the numbers it's displaying. We're using this as a way to protect our PC's USB port. And then the Nano has a, I think it's a USB mini, is that port type? But it's this type of USB connection. So basically we're going to first plug the Arduino Nano into our female header pins, make sure that the pins are aligned so that we're not off by one, and make sure that the USB port is facing up. Then we will plug this in and plug the tester into the computer, and that'll give it signal. Now, when we first launch it, it's not going to be running our code yet, so it's not doing anything with that LED. So now we go back to the IDE, and we're going to upload this code since it verified clean. So we'll click upload, and what we should see is it'll blink our LED on and off at 2-second intervals, and we can see that on the left side of the screen here. So our code worked, and it is now blinking that LED. So let's move on to a more complex code. This code really did nothing but verify that our circuit was good. Okay, so yeah, we're going to close this out, and we will open up the next program, and all of these code examples are available in the GitHub page, which will be linked with the video. So this one is called Pwm Fade. So let's launch that. And so this one is going to have a little more to it, because we're going to use the Pwm function to do analog writes. So, and we're going to also want to see what's going on so we can troubleshoot our code. So we have our LED definition. So all we're doing is defining the LED pin number, and then we're setting that pin number as an output pin. And then this next part is new. This is where we're setting up the serial output to a serial console. And we're telling it to begin serial outputting at 38400 baud. And that's because Arduino has a nice serial monitor we can use to see what's going on, and we can print messages to it so we can see what's going on in our code. So I wanted to step through that here. So in our main loop, instead of calling out delay like we did before as just a number, we're setting a variable, an integer called delay time. And we're setting that to 5 milliseconds. Now the reason that we're setting that so short is because we're going to run through a lot of iterations and we want it to look nice and smooth. So the first thing that we're going to do, we're going to use a for loop to step through all of the values of the analog write pin. And let me go to the PowerPoint for just a second to show you what I'm talking about. So the code that we're using now to fade, it's using an analog write function. And this analog write function has values between 0 and 255, unlike the digital write, which goes between 0 and 1. So this allows us to step through different intensities of LED power versus just fully on or fully off. And so that's what we're doing now is we're going to step through that with a for loop in our code. So we have our code has a for loop and we're starting at a value of 0 and we're going to run through this until it gets to 255, going in iteration of 1 at a time. We're going to write that value to the LED. And then for our serial console, we're going to print the word LED value equals, and then we're going to print what that value is. You'll notice that the serial print and serial print line are two different things. Print ln adds a character return line feed on the end. So we print, and then this is going to print on the same line and then end it with a character return or line feed. And then we delay. And we're going to do that every time for 255 times. Now at this point, when it's done with this for loop, the LED is in its most brightest state, the high state. So then we're going to start making it dim again. So we do another for loop starting at 255, going down to 0, minusing 1 each time. An analog write, serial print again, and our delay time. So not that complex of a program, but a little more to it. It's about 50 lines. Of course, half of that is comments. So let's verify our code. And you'll see off on the left here, the Arduino is still running the old code, just blinking on and off. So we should see it change there when we upload this. So our code compiled fine. Let's go ahead and upload that code. And when it's done uploading, which we can see the lights on the Arduino to say it's uploading, now we see it fading on and off. So instead of that harsh I'm on or I'm off, we now have that fading of intensity where it's slowly going on and off. Now let's take a look at the serial monitor. So if you go under Tools, you'll see Serial Monitor, which has a hotkey of Control-Shift-M. And what this will show us is the values being printed. Let me show you that serial monitor. So it's happening very quickly, but you can see the LED values are stepping up. And I have a timestamp shown here. We can get rid of that if that bothers us. Or if we want to stop to see the values, we can click the auto scroll to stop it from scrolling. Now, if this is the first time you're using your serial monitor, you might see a bunch of garbage here at first. If it's set for 9600 baud, I think is the default, what you're going to see is something like this. You have to change the baud rate to 38400 because that's what we told the Arduino in our code to send the serial signals out as. And that gives us our definitions. Okay, let's close that down and we will move on to our next code. So the next piece of code is going to be similar to the one that we just did in that it's going to use an analog write function. But this time, instead of cycling through all 255 values, we're going to set up an array that has some predefined values, and then we're going to step through those both up and down. That way it'll have a similar effect using less code. We don't need for loops, and we're just going to run through and assign that step value each time. So let's take a look at this code. let's see, where is that? Okay, so just like the other code, we define our LED pin, but now we're defining a variable outside of the main loop. So that's kind of like a global variable, I guess. But we're assigning an integer called step. And that step integer is just getting a value of 0 right now. So then we have, this is the same code we had before where we're setting the pin mode for the LED, and we're setting our serial beginning at 38400 baud. Now for our main loop, we have our delay time is an integer that we're setting to 100 milliseconds. Now we're going to leave it longer than we did before since we're stepping through sets of values instead of every single individual value. And then we're going to do our step value array. So this is how we define an array with the square brackets. I put 10 in there to indicate that it's a 10 element array. I believe if you leave that blank and just use the 2 square brackets, it will figure out how many elements are in the array. So that is my array of values that I'm going to send to the LED. Then we're going to do our analog write. Now you'll notice I'm not in any kind of a loop other than the main loop, so no for loop needed here. And this is why we set that step integer outside of the main loop. So we're going to analog write to our LED using the step value array with the array element as the step number, which in our first pass through this, step was equal to 0. So it's going to be array element 0, which is the first element in this array. Then we will use the serial print to console exactly what value we're setting. And then we're going to increment the step counter. So step is going to be equal to itself plus 1. Now, because we're stepping through this every time, we want to make sure we don't overrun our array. So we know this is a 10 element array going from 0 through 9. So if our value is greater than 9 for step, we're going to reset it to 0. And then we will delay for our delay time variable. So not that complex. It's actually less lines of code than the other version of this analog write. So let's verify our code. And we should be able to see it on the LED because right now the LED is still running the fade code up and down. So we're going to go ahead and send this new code to our board. And you can see it writing, and now we have the step code. You'll notice that this is not as smooth as the fade code, but it's not as on-off harsh as the first code that we ran, the blink code. So it's kind of that in-between. We could smooth this out by adjusting the delay time. I left the delay time high. That way we can see visually those steps in the code. Let us look at our serial monitor and we can see what's going on with that. So yeah, we can see the LED values are stepping through what we have defined in our array. So it's every group of 50 versus every single individual value that it was before. And that is the end of Lab 1. So we built a circuit, we added the code to the Arduino to control that circuit, and we did 3 different pieces of code so that we could work with it 3 different ways. I hope you enjoyed this lab, and I look forward to seeing you at the next lab that we do. Thank you again for attending.